Hi guys, my name is Nagcharan PS and I am studying second sem in Sri Venkateswara College of Engineering, and my section is Chorlet, and my given topic is types of corrosion and prevention of corrosion. Here there are two types of corrosion. One is the differential metal corrosion and another one is the differential aeration corrosion. In the differential aeration corrosion, for example, when the metal rod is immersed in NaCl solution, the part of the metal which is exposed to lower concentration of oxygen acts as anode and undergoes oxidation, and the metal gets corroded at the anode. And the other part of the metal which is exposed to higher concentration of oxygen acts as cathode, and a reduction occurs at cathode and the metal gets unaffected at the cathode. Here there is an another type in the types of corrosion: differential metal corrosion. How it occurs? Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with having lower electrode potential acts as anode and undergoes oxidation, or the metal with higher reduction potential acts as anode and undergoes oxidation. In the oxidation, the metal is converting into its metal ion by giving the electrons and gets corroded. And the other metal with higher electrode potential acts as cathode, or the metal with lower reduction potential acts as cathode. In the cathode, the metal ion is converting into its metal atom by accepting the electrons. At the cathode, reduction occurs unprotected from corrosion. At the cathode, the metal get unaffected. This type of corrosion is known as galvanic corrosion or differential metal corrosion. Differential metal corrosion is also known as galvanic corrosion. Reactions of differential metal corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. In the electrochemical series, if the difference between the two metals is higher, then the corrosion occurs at the faster rate. The reactions may be represented as: at anode, metal gives rise to its metal ion by giving the electrons. At cathode, reduction reaction takes place. It means metal ion is converting into its metal atom by accepting the electrons, depending upon the nature of the environment. Here, for example, 2 moles of H plus ions is combined with 2 electrons gives rise to hydrogen molecule or H2 molecule. Or another example is 2 moles of water molecules combines with 1 mole of oxygen plus 4 moles of electrons gives rise to 4 moles of hydroxyl ion. Here the OH ion represents the hydroxyl ion. These are the reactions which representing the differential metal corrosion. Here, the examples of differential metal corrosion: when iron is in contact with copper. Here, the electrode potential of copper is 0.34 volt and the electrode potential of iron is 0.44 volts. Becomes anodic. Here, iron becomes anodic because iron having lower electrode potential than copper, and the at anodic region undergoes corrosion, whereas copper becomes cathodic and remains unaffected. And the another example is tin coating copper vessel. Here the tin coating copper vessel. And the few more examples of differential metal corrosion are steel pipe connected to copper plumbing. Here the steel pipe is connected to the copper plumbing, and bolt and nut made of different metals. Here the bolt and nuts are made of different metals. Here, how can we control the metal, or how can we prevent the metal from corrosion? Here the one method is galvanization. how it takes place or how it occurs. The process of coating zinc on the base metal. The process of coating zinc on the base metal surface by hot dipping is known as galvanization. Here we can consider iron steel as a base metals. The galvanization process is carried out as follows. The metal surface is washed with organic solvents. The organic solvents are carbon tetrachloride, that is CCl4, and toluene, and another one is benzene, to remove the organic matters. The metal surface is treated with dilute H2SO4 to remove rust and other deposits. The metal surface is treated with dilute H2SO4 to remove rust and other deposits. Then it is well washed with water and it is air dried by passing with hot water. The metal is treated with a mixture of zinc chloride, that is ZnCl2, and ammonium chloride. The metal is treated with a mixture of zinc chloride, that is ZnCl2, and ammonium chloride, that is NH4Cl. Solution which prevents the oxidation of the coated metal, that is, if the metal is treated with a mixture of zinc chloride and ammonium chloride, solution which prevents the oxidation of the coated metal. Then the metal is dipped in molten zinc at 450 degrees centigrades. If the metal is dipped in molten zinc at 450 degrees centigrades, excess of zinc on surface is removed by passing a pair of hot rollers, which removes excess of zinc and produce thin coating, which removes the excess of zinc and produce thin coating. Here the process of galvanization is represented in the diagrammatic form. We can go through that, and thank you.